A chemical reaction is given in this question, that is a mixture of 2.3 gram of formic acid and 4.5 gram of oxalic acid is reacting with concentrated sulfuric acid. Then the produced gaseous mixture is passing through potassium hydroxide pellets. Then we have to find out the mass of remaining product in this reaction mixture at standard temperature and pressure. Let's consider the first reaction, that is the reaction between formic acid and sulfuric acid. So they will produce carbon monoxide and water as the product. Sulfuric acid is a dehydrating agent, so the produced water can be absorbed by the sulfuric acid. So the remaining will be carbon monoxide in this reaction. Now let's find out the number of moles of formic acid and products obtained in this reaction at the starting and final stage. At the starting stage, we can see 2.3 gram of formic acid is reacting. So the number of moles of formic acid at the starting of the reaction will be mass divided by its molar mass. So that is 2.3 divided by 46. 46 is the molar mass of formic acid. The amount of carbon monoxide and water produced at the starting of the reaction will be 0, means the reaction is not yet started. After the completion of the reaction, at T is equal to T, the formic acid will completely convert into carbon monoxide and water. So the moles of formic acid will be 0 and moles of carbon monoxide and water will be 1 by 20, because all these formic acid will be converted into carbon monoxide and water. The ratio is 1:1:1. So it will be 1 by 20 each. Now the second reaction takes place in the same reaction mixture is oxalic acid react with sulfuric acid. Then the products are carbon monoxide, carbon dioxide and water. Water will be again absorbed by sulfuric acid, and it is given here the produced gaseous mixture is passing through potassium hydroxide pellets. So the carbon dioxide will be absorbed by potassium hydroxide. So the remaining gas in the second reaction is carbon monoxide, because CO2 and H2O are removed. Now we need to find out the number of moles here. The mass of oxalic acid is given as 4.5. So the number of moles of oxalic acid at the initial stage of the reaction will be 4.5 divided by 90. Here 90 is the molar mass of oxalic acid. So it will be again 1 by 20. Before starting the reaction, the amount of the products will be 0. After a time t, the number of moles of oxalic acid becomes 0 and number of moles of the products will be 1 by 20 each, because again the ratio is 1:1:1. So from both these reactions it is clear that the remaining product is only carbon monoxide. So the total number of moles of carbon monoxide present in this reaction mixture is 1 by 20 plus 1 by 20, that is 1 by 10 moles. Now we need to find out the mass of the product remaining in this reaction mixture. We know that the number of moles can be found out by the equation mole is equal to mass divided by molar mass. So mass will be equal to number of moles multiplied by molar mass. Hence we can write 1 by 10 multiplied by molar mass of carbon monoxide, that is 28. So the mass of carbon monoxide remaining in this reaction mixture will be 2.8 gram. Option D is the correct answer.